Here is a basic model representation of a plane. This is a fuselage and it has wide wings on both the sides of it. These wings carry huge mass of fuel required for the whole flight. And these wings also have massive jet engines on both the sides which weighs tons together. So there will be a lot of gravitational force that is acting on it. So why the wings are not fallen off? Guys, now we are going to conduct an experiment that how an aeroplane wing will work. For this experiment, we need some bent straws, some straight straws, insulation tape, string and 2 water bottles. First, we need to make some square and rectangle shapes like this using straws. To make the shape rigid, we need to add some shapes like this. After doing the square and rectangular shape, we're gonna make a structure like this. For these structures, we will add some straight straws to give more strength to the structure. After attaching those complete structures of the wing to the water, we are going to get a model like this, which represents the whole plane. The weight of one wing will act as counterweight for the other. So, this balances the weight on both the sides. Thus, the wings doesn't fall off.
So, as my friend told that tension on the string balances wings on either sides, we are going to illustrate various forces acting on a plane. Here we have a model of a plane. So basically, weight of the body acting in downward direction. The counter force for this is called lift, which acts in the perpendicularly upward direction. If these two are only the forces, then it will be able to move just up and down. So there should be a driving force which pushes the plane in the forward direction. This is generated by the engines. These engines accelerate here at the back, generating thrust force in the forward direction. This is basically the replica of Newton's third law. We have an opposing force to the thrust called drag. The major type of drag is pressure drag. This pressure drag can be minimized by designing the plane aerodynamically. Perhaps you must be thinking how the lift is gained. This depends on the factor called angle of attack. The aircraft can pitch up and down, but they still are traveling in the forward direction. The angle formed by the horizontal direction of travel and nose of the plane is called angle of attack.
Here is a picture representing all the forces. Guys, here I am going to explain how the lift takes place. And the lift is depending upon the shape of the wing. So you can see that the wing is not flat at the top. It has curvature. So this curvature helps to gain the lift. Here is how it works. Let us draw a simple wing. It's having more curvature in the front and it is moving towards the right direction. And I am drawing the direction of the airflow representing the streamlines. There is a tapered shape at the back portion of the wing so that it can reduce the turbulence and drag force. Imagine some amount of air in this region. Some of the air is going below the wing and some of the air is going above the wing. And here we can see that the streamline gets bunched up on the top surface of the wing. This causes the air to be pushed more on the top surface than the below. So you can see that air in the front has larger area to flow compared to the top surface of the wing. This constriction causes air to flow faster. This leads to the less pressure on the top surface of the wing. This is important principle here that fluid moving more quickly exerts less pressure. But the pressure is high at the bottom surface when compared to the top. This difference in pressure causes net force acting upward. This generates the lift.